Welcome to video 3. My name is Kunal. This is the last of our 3 videos covering the exam section 1 and it's all about MLflow. MLflow is the backbone of machine learning on Databricks. It handles experiment tracking, model packaging and model registry. The exam tests your knowledge of specific API methods, so we'll be precise about the code and let's dive in. We'll start with MLflow tracking, how you log and retrieve the experiment data. So what is MLflow? MLflow is an open source platform for managing the entire ML lifecycle. It has 4 components: tracking for logging experiments, projects for reproducible runs, models for packaging, and registry for versioning and governance. On Databricks, MLflow is pre-installed on every ML runtime cluster, so there is zero setup required from your side. For the exam, focus on 3 components: tracking, models, and registry. Now let's talk about manually logging metrics, artifacts, and models. The exam actually expects you to know how to manually log different types of data to an MLflow run. You start with MLflow.startRun to begin a new tracking run. Then you have 4 types of logging, right? First one is MLflow.logParam, which records hyperparameters, things like learning rate, number of trees, regularization strength, etc. Then you have MLflow.logMetric that records evaluation metrics like RMSE, accuracy, and F1 score. MLflow.logArtifact actually saves the file like plots, data samples, and configuration files. And finally, MLflow.sklearn.logModel, or the equivalent for other frameworks, that actually saves the trained model itself. When you are done, you call MLflow.endRun, or better, use a with statement like with MLflow.startRun, and everything is automatically cleaned up for you. Know the difference between params, metrics, and artifacts. Params are input configuration, metrics are output measurements, artifacts are files, and models that you build are a special type of artifact. The exam actually tests this distinction. Now let's talk about identifying the best run with MLflow Client API. A common exam question asks how to programmatically find the best run in an experiment. You use the MLflow Client API, instantiate it with client equal to MLflow client, then called client.searchRuns with 2 key arguments. The first argument is filter string. This actually lets you filter the runs by metric values. For example, metrics.rmse less than 0.5 returns only the runs where your RMSE value is below 0.5. The second argument is order by. This actually sorts your results. For example, metrics.rmse ascending sorts your results from lowest to highest RMSE. The method actually returns a list of run objects. The first element in that list after filtering and ordering will be your best run. You can access its run ID, parameters, metrics, and artifacts. On the exam, when they describe a scenario where you need to find the best performing model programmatically, the answer is use search runs with filter string and order by. Okay, remember it, search runs. Let's talk about MLflow UI. What information is available through MLflow UI? The exam will actually ask for what information is available in the MLflow UI. Let me walk through that, what actually you will see. The experiment view shows all the runs with their metrics. You can compare them visually with charts and tables. Each run has a detailed page showing parameters, metrics, artifacts, tags, and duration. You can see the model that was logged and its requirements. Metrics plot shows how metrics changed over training steps. This is actually useful for monitoring conversions. The artifact viewer lets you browse and download log files. The compare mode lets you put multiple runs side by side to see the differences in parameters and metrics. And the model registry view shows all the registered model versions, their current aliases, and the lineage information, which run actually produced which version, etc. Now, let's talk about model registration and the Unity Catalog registry, including the transition from the old workspace registry. So, registering models in Unity Catalog. To register a model in Unity Catalog, you called MLflow.register model. The first argument is the model URI, typically like runs./ followed by the run ID and the model artifact path. The second argument is the model name, which must follow the three-level Unity Catalog namespace like catalog.schema.model name. You can also register the model directly from the MLflow UI by clicking the register button on a run. Each time when you register a model in Unity Catalog, it automatically creates a new version. So your first registration is version 1, the next version will be version 2, and so on. Unity Catalog adds powerful governance, access control through ACLs, lineage tracking showing which data and code produced each model version, and cross workspace sharing so other teams can discover and use your models. So now let's talk about Unity Catalog registry versus workspace registry. The exam asks you to compare Unity Catalog registry with the workspace registry. We'll first talk about the Unity Catalog registry. The Unity Catalog registry uses a three-level namespace, catalog.schema.model name. It provides centralized governance across all workspaces, fine-grained access control with ACLs, cross-workspace model sharing, and full lineage and audit trail. On the other hand, the workspace registry, which is the legacy option, uses a flat namespace with just the model name. Governance is limited to that single workspace. Permissions are basic. There is no cross workspace sharing, and Databricks is actually actively deprecating it. On the exam, whenever a question gives you a choice between registering in Unity Catalog versus the workspace registry, always choose Unity Catalog. You know the advantages very well. Tags and aliases for the model management. The exam tests two model management features, tags and aliases. Tags are key value metadata that you attach to the models or specific versions. For example, you might tag a model with team names like team equals fraud, or a use case like use case equals chain prediction. You set tags with client.set model version tag, and you remove the tag with client.delete model version tag. Aliases are named references pointing to a specific model version. The common pattern is champion versus challenger. The champion alias points to the current production model, and the challenger typically points to a candidate model that is being tested. To promote a challenger model to champion, you call client.set registered model alias with the model name and the alias champion and the version number of the challenger model. This actually reassigns the champion alias to the new version. You can load a model by alias using the @ syntax. For example, mlflow.python.load model followed by the model path and with @champion at the end. This is very powerful because your serving code always loads the champion model, and you change what champion points to without modifying any code. This alias system actually replaces the old stage-based approach where the models had stages like staging and production. On the exam, always use aliases and not the stages. So what are the key takeaways from this section? So here are some of the MLflow essentials for the exam. Know all four manual logging methods: log param for hyperparameters, log metric for evaluation metrics, log artifact for files, log model for train model. Use search runs with filter, string, and order by to programmatically find out the best run. Register models in Unity Catalog using three-level namespace. Aliases like champion and challenger, they have replaced the old stage-based transitions, and always prefer the Unity Catalog registry over the workspace registry. So this kind of completes our coverage of exam section 1 that covers the Databricks MLflow platform. Over these 3 videos, you have learned about MLOps, ML runtime, AutoML, feature store, and MLflow. In video 4, we will actually shift to section 2, which is about data processing and feature engineering. We'll cover summary statistics, outlier removal, imputation strategies, encoding, and log transformations, and a lot more. See you there. Thank you.